So now that that's done, we can finish with the component interactions. You can see them all there, and that's all we need to do for that. So next we have to do the fixtures, and these are the boundary conditions, so your pin joint and your roller joint. So as we talked about in the class, we don't want to use the fixed geometry or the roller because there might be some extra conditions that SOLIDWORKS has implied. So we want to, manually set up our fixed geometry. So we'll choose advanced fixtures, and we'll start with this left side here. So what we want to do is choose an edge that our fixed position will be on. We don't want to choose a face, so either we can, depending on your geometry, if you might have like a curved area here, or it could be square like this, you can either choose this edge here or you can choose the inside edge. Now, due to the nature of 3-point bending and the geometry of our fixture, a more accurate representation would be to choose this inside edge here. So try and pick something that is, sort of away from the far edge here. So we'll choose this edge, and the two edges on the other side. And now we need to choose a reference plane for our direction. So we'll just, any plane is fine, maybe the front plane. And now here we can set up the translations. So if we turn all these on, we can see that we're going to be constrained in the directions of those arrows. So we can't move in Y, X, Y, or Z. But we can, we are free to rotate on those lines. So we can confirm that, and that will be our pin joint. And if we hover over that, we can see what our constraint is. So we've got XYZ translations are constraint to 0 millimeters. So there shouldn't be any translation movement in those directions. And on the other side, we can put our roller. So we'll just create the same advanced fixture. We'll choose the same 4 lines here. And our reference plane will be the front, and we'll turn all those on again. However, we'll start by turning off the first one, and that we can see that from those arrows we're now constrained only in the Y and the Z, so the X is free to move. So that's our roller joint there. So yeah, we can go ahead and confirm that. And now we need to define the loads. So we're going to right click external load, choose force, and we're going to choose that split line that we created earlier. Now looking at those purple lines, that's showing us the direction of the force, and clearly we don't want it to run along that line. So what we want to change is this here. Instead of normal, we want to choose select direction, and here we want to choose a reference. So we'll choose the front plane again, and now we can turn on some of these forces. So clearly that's not right. That looks much better. So we're now in the Y direction, and of course we're going in the positive Y, but we want to go in the negative Y because our force will be applied downwards. So we'll just check this box here, reverse direction, and there we go, we've got load correctly in position with the correct direction. And now for our magnitude of the force, we want to put in 14 newtons, and then we can confirm that. So we've got 14 newtons acting in the negative y direction along our split line. So finally we have to create our mesh. So we can just right click that and go create mesh, and we'll get a few settings that we can play around with here. Now, as we discussed, meshing is a very complicated and long topic that you'll learn later on in your future courses. So for the purposes of this assignment, we'll leave, we won't spend too much time on creating a suitable mesh. So what we can do is just make our density as fine as we can, keeping in mind that the finer we go, the higher the computational time, so the slower the simulation will run. But generally speaking, the finer the mesh, the more accurate our result will be. And of course we've got some advanced mesh settings here, but it's okay to just leave those alone. And of course some more settings in here where we can change the mesh, but let's just confirm that on the finest setting. And a little box will appear here and it will begin meshing. Sometimes that can take a minute or so. Cool, and now the software will display the mesh. Cool. So now we can go ahead and run the study. So we'll choose this button up here. This mesh is quite detailed, so it's running a little bit slow. And we'll get another little box that appears showing us the progress of the simulation. So these simulations can sometimes take a while to run, depending on how complex your model is. So I'm going to leave this to run now, and I'll skip ahead and return when this is finished. So I'll see you in a bit.